So, hypothesis test for one mean. Again, we're going to do it the long way, and then the shorter graphing calculator way, using the 4-step solution method. And this time, our example, we're going to talk about something called SNAP benefits in the States. Basically, it's like food assistance for those people that need it. Okay, it stands for Supplemental Nutrition Assistance Program. And SNAP benefits over the month should cover the following food items for one person. And you can see it there. Okay. So the question is, do SNAP benefits actually cover these food costs? If you went out and bought all this stuff, would it be covered? So in the year 2020, the maximum monthly SNAP allotment for a household for one person was $194. Okay. But somebody did a simple random sample of 31 US grocery stores, found the average cost of the essentials bundle, all these items listed above, was $199.45, clearly higher than the $194 allotted. And it also had a sample standard deviation of 25.98. So the question is there convincing statistical evidence that the maximum SNAP individual monthly allotment is not covering all of these items? Okay, because in the sample, it was $5 more. So is that common, the sample we got, or is that maybe just a higher result due to chance? Okay, that's what we're eventually finding out. How do we know if we're doing a hypothesis test? What words do you look for in here? Especially towards the end. What words are you looking for that says, oh, hypothesis test? Convincing statistical evidence. Okay? Convincing statistical evidence. If you were asked to do a confidence interval, that's easy. Would be asked, construct a confidence interval. Okay? So, remember how we start these things, these hypothesis tests? We start with our null hypothesis and the alternative, sort of the alternate. So in words, the null is, no, food stamps, the 194 covers it. Okay? And the alternate, what we're trying to find convincing statistical evidence of is, no, it's more than 195. So how would we say that using mathematical notation? Well, the population mean would be 194. And the alternate would be that, no, it's greater than 194. Okay? And just be careful about the wording. Like even if it said, is the SNAP benefits different from 194, that dictates what kind of notation you have to use. Okay? And then of course, mu is the true mean price of the essentials food bundle. We have to add that as well. So basically what it's coming down to, the result that we got in our sample, how unusual is that? So we're going to do the math to show how unusual it is by finding the p-value, which is that's how we make conclusions. In the hypothesis test, whether it's a mean or a proportion, we look at the p-values. Okay, so in a world where the null is in fact true, how likely is the data, the sample, 199, whatever it was, how likely is that? And we have to look at the sampling distribution and we need some numbers along with the type of the sampling distribution. Now remember, with means, we have to deal with t-distributions, not normal distributions. And just remember, t-distributions, it takes the same shape as normal distributions. It's got wider tails, and it's a little bit lower at the mean. But that depends on the degrees of freedom. As the degrees of freedom goes up, it gets very, very close to a normal distribution. So our sample then follows a t-distribution, and the average of the samples, if we did many, many samples, would be equivalent to the sample we got, that 199, no, sorry. Do I have the right notes? Why do I have different notation here? No, this should be, yeah. Does yours say that? It says this?
Yeah.
Shoot. I didn't change it. And the standard, yeah, that's fine. That's fine the way it is. But sorry, the average of the sample is the null value. Changed it in my notes. So, according to our calculations, we're using a t-distribution, like so. If we did many, many samples, it would average out to the null mean, which is 194. And the standard error of that sampling distribution would be the standard deviation of the sample that we got, which was 2598, divided by the square root of the sample size, and it was 31 grocery stores, so square root 31. And then if we just finish these calculations, we get the standard error is approximately 4.67. Okay. So remember, we're assuming the null is true. We're assuming that it's 194. But in the sample, we got 199.45. Which is about here. Okay, so I want to know how, given that we're assuming this is true, how likely is it that we got $199.45 or even greater? Okay, what's the probability, therefore p-value, of getting $199.45 or greater? And then, of course, we want to test that against the 5% guideline. Usually we use alpha equals 5%. So remember, to do this the long way, we need to calculate the t-statistic, and then from that we can get the p-value, which tells us how much this area is, or what's the probability of getting 199.45 or greater. Okay, so the t-test statistic tells us how many standard errors the sample mean is above or below the null mean. Right? We want to find out how many standard deviations that is. So we have to calculate that using the calculations that we got above. So remember, t is going to be this. So our sample mean, okay, we're going by the null mean, 194. sorry, 199.45. The null mean is the next one. This is the null mean, 194. Divided by the standard error that we got above. And that error that we got above was the sample standard deviation divided the square root of the sample size, which was 4.67 it worked out to. So that means T is going to be approximately 1.17 standard errors away. Before we find the probability of getting that, does that seem like it's really far away? Like it's really extreme? 1? No, it doesn't, right? Okay, so we're probably going to get a result that says, you know what, the sample mean we got was not unusual. Okay? That we could have got that by chance. But we need to go a little bit further to prove that. Okay? So to find the p-value, this is where we have to use a normal calculation, but remember we're dealing with means. So we're not using normal anymore, we're using t-CDF, not normal CDF. We now know that this is 1.17, right? So therefore, we are trying to find our lower value is 1.17. Our upper value is something ridiculously high. And if you look at TCDF, it also asks for the degrees of freedom, which are? So in this case, it would be? 30. Good. Okay. And when we do that, we get approximately 0.126, or about 12.6%. Okay. Remember, we said anything over 5% is not considered unusual. Anything under 5% is considered unusual. And remember what the p-value does, okay? Because I know some of you had some difficulties with explaining this, okay? The p-value shows a 0.126 or 12.6% chance of getting a mean of, and the sample mean was 199.45 or greater. So even though this 199.45 is bigger than the 194 allotment, it's not unusually so. Okay, so therefore, not convincing evidence. The essential bundle is a higher cost than 194. Yeah.
Where's the upper, the 18, or is that just a random way we?
Oh, sorry, that's 1,000. Yeah, remember we just choose a big number like 1,000 or 10,000 because I mean, you could, 1,000, like here's 210, 1,000 is way out here, right? But the area of this little tail way out here is really, really small. Okay?
Okay.
But we do want to cover it. Sorry, should have said, failed to reject HO. Maybe we have to add that. Okay? So that's the long way. The more efficient way, using the four-step process, we can use our graphing calculator to calculate the standard error for us. It'll also calculate the number of standard errors it is away, and it'll calculate the p-value. It'll do all of that in one graphing calculator function. So again, same question at the 0.05 significance level. So that means if our probability, the probability of getting our result is less than 0.05, it's unusual, we reject HO. First step, state. What are we doing?
You're looking up the hypothesis, right?
Sorry?
Because you opened up the.
Yep. Okay. And actually, we don't even have to, you can put hypothesis test, but the big things you want are HO, HA, and what mu represents. So remember, we said, okay, we're going to assume, no, everything's fine. The cost for the SNAP benefits, it's fine. But we are trying to find convincing evidence of, no, it's greater. And we have an issue. Okay? And then, of course, you have to define what mu is. It's the true mean price of the essential bundle. Next, plan. We will conduct, how are you going to say it? One sample, and then the letter. T test. Yes. One sample T test. And then we can go ahead and do that if were the stores randomly chosen?
Yeah.
Yeah. So random selection of the grocery stores. %?
Yeah. Yes.
Yeah, because 31 is definitely less than 10% of all US grocery stores that are out there. And the last one, large sample. Have we met it? Yes. Just barely. Because our sample size is greater than or equal to 30. So we're good, right? Once these are met, that means we can go ahead and do the actual calculations. And what are we going to do for this one? 2 t-tests in your graphing calculator under tests. Okay? So when you go to your graphing calculator, we go to tests, we go to t-test, we're going to enter stats, and now we enter everything that it asks of us, right? So we've got a t-test. What is the null mean? 194. What is the sample mean? Actually, I'll write it horizontally. 199.45. Standard deviation? 4.67. You sure? It's the standard deviation of the sample. Not you. You did the standard error. That's okay. What would it be? Not 1.17. Yeah, it's right from the first page, right from the beginning.
25, no. 25.
No,
Yeah, okay.
but it's 2598, right? Because that's the standard deviation of the sample. When we went and found 4.67, that was the standard error, right? Which we have to use with the distribution when we want to do it the long way. So it's 2598. That's good. We want to make sure we sort this out. And then n is 31. And what are we trying to prove? Greater than the null mean. And then, of course, you'd go to calculate. And, of course, we should get pretty much the same answer when we did it the long way. So if you enter all of that and then calculate, and remember, you're just looking at the p-value in the middle. And what do we get? 0.126. Same as when we did it the other way. So you can see the relationship between the two. Did you get it? T-test? Did you do t-test?
What number did you get? Oh, because my standard deviation. Yes. It's 2,500.
Oh. So, our conclude. What do we say? Because, yes, but because our p-value is greater than alpha, we fail to reject HO. We don't have convincing evidence. It's the same sentence that we did previously. We don't have convincing evidence. The true mean, essential, grocery price is greater than $194. That's what's allotted. You can say it's greater than what's allotted, or just say the amount. 194. Okay. Extra question. Given what happened, could I have made a type 1 or type 2 error? I know, it's hard to. Do you remember type 1 and type 2?
To reject. So type 1 is when you accidentally reject, and we failed to reject, so you could make a type 1.
You're.
No, you could have made a type 2
Right,
with your error.
right. Right. I was a little worried about you there for a second because you got so excited and then you said type 1. And I'm like, no, say type 2.
No, but you could have made a type 1. No. I understand.
There you go. Good job. Okay. Any other questions about this? And you can see you can see how similar it is to a hypothesis test for a proportion. Because remember, that's going to be one of the big things, right, is sorting all those out. Because how many possible scenarios do we have again? 8, right? You could have a hypothesis test for a mean or proportion, hypothesis test for 2 means or 2 proportions, confidence interval for 1 mean or proportion, confidence interval for 2 means or 2 proportions. So we got to make sure that we keep working on sorting all those out. Okay, yeah.